This video will simply demonstrate the capabilities of this program, and we assume by now that you have already downloaded the program and unzipped it. When you unzip the program, this is what appears on your screen. Help files and CWRU exec. Let's double click on exec. The first screen that you see is a marquee screen that simply gives you a little bit of the history of the database, when it started and with whom. You click it off, and then you get to the heart and soul of the program. You got three frames in here: the tree view, the collection box, and the information box. In the information box, you see already 273 tests. Child note count 273. Total number of tests in this database is 261. Well, you can have this whole list in the manual, but for the time being, let us look at some of the capabilities we have here. You're looking on the left-hand side to all the tests conducted on Cube and on Hollow Cylinder. If you want to examine, for example, a test on Hollow Cylinder conducted on Reed Bedford Sand, you are going to click Reed Bedford Sand. We have really three sands, one of them being French and two being from the United States, and we have a set of tests that were conducted on each one of those sands on a cube and in a hollow cylinder. Let's look at the Reed Bedford Sand conducted on hollow cylinder. When you click on it, you get all the tests conducted on Reed Bedford Sand in this database. A quick word about those letters and those numbers. They are actually defined in the user's manual, but it's always nice to hear about them at this stage. We have two letters at the front here, a D and a G. The D stands for direct tests. A direct test is a test in which the cell pressure is kept constant and the axial load increased or decreased, which means that the mean effective stress is changing constantly. A generalized test is a test in which the axial load is increased or decreased and the lateral pressure coming from the cell is decreased and increased. So the mean stress will remain constant. The second letter refers to the density of the sand. L stands for loose sand and N stands for dense sand. The next number that you see over here refers to the cell pressure, or the effective cell pressure. And the last number refers to the coefficient B, which is by definition sigma 2 minus sigma 3 over sigma 1 minus sigma 3, and it does locate the intermediate principal stress with respect to the maximum and the minimum. Looking at these tables that are in your manual, we can have a quick explanation on what those numbers mean. For example, if I have the number 1, it means that the inclination of the principal stress with the axis of symmetry in the hollow cylinder is 15 degrees. And of course, as is well known, this inclination by means of sine square the angle 15 degrees is a direct measure of the coefficient B. In other words, sine square of 15 is 0.067, so the coefficient B for this number 1 is 0.067. Regarding the last number that you see over here, and the first number put together, they come at the end of the name of the sample. As you can see here again, the first number, which is the cell pressure, is lined up in this table here. And we're giving here the effective stress pressure in PSI and in KPA. You have, by the way, as we may have mentioned before, the choice of choosing either the international system of units or the traditional US standard units. Once you make that choice, every measurement that you see will be in one of the two systems. Let us get back now to all that list of read Bedford sand or any one of the other sands that we have. The numbers appearing in green are essentially the tests that the predictors during the international workshops that we had asked to have to calibrate their constitutive equation. We send all this information to them as mentioned in the first video, and their answer came. Ask them also to predict what appears here in red. So the red numbers over here, the red samples over here will simply say these are the tests that we asked them to predict. Let's try one of those tests. Let's say DL12. If you click on it, automatically all its properties appear in the information screen down here, information box. And as you can see, this DL12 has the effective cell pressure is 207 kPa. We have a loading pattern. We have a mean stress, which is variable because it's a direct test. The p-value is 0.28. If you double click on it, it appears in the collection box. And this is where you start from this point and try to either display the data and all the variables that has been computed, or plot one variable against the other. Let's start with display. Click on display. Well, as you can see, I have clicked on it, but I didn't check it up here to begin with. So you get that frame saying, hey, check it first. Okay, I will. And I'm checking it here. Once I check it, I can display or plot. Let's try display. And here is this particular test. The student that run the test is Piero Puccini. We have 40 points on here. Height, area, volume, inner radius, these are all the initial dimension. If you had chosen the traditional US standard unit, you would have had all this in foot, inch, etc. Now, as you go down those columns, you can see the height, since that is a combination of axial and torsion, the height of the sample, the mean radius, remember that's a hollow cylinder, so there is a mean radius, the area of the sample, of the cross-section, and the volume of the sample. And then all those values are calculated automatically by the program. The axial load, the axial deformation, the cell pressure, effective cell pressure, the pore water pressure. Here, we're running actually drain tests on sand, but this is the back pressure that has been applied to the sample to avoid air bubbles. This is the volume change, the torque that is applied, and the angle of rotation. With this data, everything else has been calculated. Sigma z, epsilon r, tau theta z is the shear stress, gamma theta z is the shear strain. And all those variables are defined in the manual, but they are the normal ones that are used in soil mechanics. Let's look at the plotting routines that we have. We go back here and we click on plot. Here is the name of the sample that you are examining now. You can type here the name of this sample so it appears on your screen, and then of course if you print it, it will be on your printout. Choose the y-axis. Any one of those variables can be put on the y-axis. Let's take, for example, one that just about applies everywhere, the octahedral shear stress. Click on it. It will appear on the y-axis. You want an x-axis, take the octahedral shear strain, and then press plot. Now with this frame, you have the possibility of choosing the range, the tick space for the x-axis, for the y-axis. Normal scale, we can also get some logarithmic scales on the y-axis, and then click on plot. And here is the graph that we mentioned before. You can look at this graph and you can pick up any point on it with the crosshair. Click, gives you exactly the coordinates of this point over here as well as the area under the curve. Now on the right hand side over here, you can see property colors. Well, if you wish to change the color, you can take any one of these. Dark orange. Here we go. And here is the color has changed. The reason for color change and choice of color is that we are going to see in the next video the capability of superimposing the stress strain curve or any other curve for different samples, and even for a superposition of cube and hollow cylinder. You have one here regarding the property of the width of the line. This is number 3. If you want a thinner line, you go to number 2. If you want another thinner line, you could go to number 1, which is very thin. Now going back to number 3, we can stay here for a second. And of course, if you want to change something in the style, you are going to get here line, S-spline. This is the way the coordinates have been joined together. And really that's a way to operate this program. It's as simple as that. However, to get out of this frame, you have to cancel frame by frame going backwards. Cancel this, and you get back here. In the next video, we will superimpose samples and we can give some explanation on what is showing in the tree view and other views in the program.